right, let me see if I can pull up the chat. Okay. And we got it. Okay. I have the chat. Looks like the screen cap's working. Ah. Let's get some better sound going. All right, compiler and cookies. I need to update the title. Do that. And cookies. All right. So what I've currently done is, here's an example program that we've been compiling, and we're implementing inlining calls in our bytecode. So forget about this example for a minute, and go back to our addition example. We'll do the more complex add that has a branch. What we're trying to do is call add52, and ultimately what we want is for the call to be inlined, the call to add to be inlined into main, and the call to add, the add function itself has a branch. It's got an early return, so it's got a few different basic blocks, and the goal is to inline it all and then simplify the control flow a little bit too. Because once we inline it, we still get a jump to the inlined code, and we're not really able to like optimize anything further just by inlining it. So that's the current goal. And what we're realizing is that with some of our code, we're generating a fee node that only has one incoming, and then our CFG simplification doesn't handle it well. And so let me show how that looks. So what I'm going to do is turn off optimization for a minute, the new IR optimization we've implemented. Run the sandbox file, and what we will see is, well, it says nil node is not mine, which is a new error that I've never seen before. Okay, what have we changed? We're not simplifying. I started yeah, I'm not sure. How are we looking on just a test? Nope. No, it's not mine. All right, we gotta track this down, I guess. It's in validate unit. Oh, okay. I did trying to flesh out the module validation a lot more now that I'm mucking around with the blocks and instructions, because it's gonna save me a lot of debugging time if I can validate things. So it says nil node is not mine, so which means we're doing a get. Nil node is not mine. So this is what I changed. I'm trying to add validation for a fee, specifically a fee's incomings. And let's just give it another run. And where we are is It says 2825. No. Am I crazy? Well, that doesn't make any sense. Oh, because I hadn't saved, maybe. What was unsaved? Validate unit 2829. Whoops. Header handles unit.blocks. So it's not happening down here in the new fee stuff. All right, let's figure this out. All right, debug assert mine. And enter nodes from, and from line 2829. So unit.blocks is corrupted, and it's validate unit being called after compile function. I don't think it's that. Sure, we were starting to do the main task of the day. Well, I really thought I was in a clean state to start work today, but no, we're not. 2829. It's just not really clear to me. I'm still calling CFG simplify and IR opt, IR optimize. That's not enabled yet, so that's not happening. And this one's disabled. Well, I don't really have a great way to validate that this linked list is correct. I mean, I have sort of like I have a debug function to validate a linked list. Not debug assert mine. Assert valid, right, of a linked list, and this would be unit.blocks. So I guess I have this. Where are we corrupting the blocks? Man, we get to hear. That's wild. Handles, iter handles from, list dot first. I'm just gonna call iter nodes from. And that's going to assert mine. And it's nil. So from node's nil, which means list.first is nil. I mean, sure. first. That's a block index. I think I can raw index, yeah. Starting off with a little no context debugging. Okay. Who has no blocks? Which unit? Name. I think I have a unit name. String. It's the unit ID. I don't know. Okay. So cool, it's an external call. It has no blocks, and now validate chokes. Why didn't iterating I know what is happening now. It's just an empty linked list, and this way, because I switched to iterating handles. I was previously iterating a different way. So the last thing I did off stream was probably change the way we're iterating over this to something that happens to check that the start node is mine, and then that's where it all comes from. Let's stop first. I think this should handle it. I mean, this should probably also just handle from node. It's not even that. It's like if list is empty, if the list isn't empty, oh, I guess we can do this, right? We can just only check that it's ours if we're non-empty. And then we'll just get an iterator that will yield no items. Yeah, and I think this is my only function that takes a node that is fine to take a nil node, because internally it's just how I iterate from the start. I call a more generic iteration that starts from any node. So we can clean up our prints. Let me share the stream here. Copy link. Attempting some CFG simplification. Attempting some IR optimizations. All right. Now droves of people are going to come from my Twitter following. Fee incoming value wrong type. That's cool. So my new validation's failing. Let's make it a better message. I can't really print print them very easily. I221 phi, this type, sum union empty empty, sum union empty empty, and what are you? They are the same type. What? Wonder what's going on there. They have different IDs. That makes sense. I don't actually have anything that checks for physical types for equality. Because aggregate types, which these are represented by IDs in a pool, so they'll be different. I could compare the contents. How's the sound? Let me make sure. Yeah, sound's coming through nice. I'll leave this off for now. I already addressed that. And let's run it again. Let's not get too distracted from our main task. All right. Hello World works, but does our full test suite work? It does. Okay. Let's just clean our slate a little bit here. I don't really want to commit that actually. Yeah, this is all kind of in flight, so, and that's why things were left a little messy. But let's start our main task. So what I wanted to do was compile Sandbox and look at the code. And I don't think it is optimized. Yeah, inline ret. Yep, nothing. Yeah, it says optimized unit, but that's just the way the log message works. So here is the expression that we're running. If we go to a.k1, it's this. So when I say static, run this code, this block gets compiled to an IR unit, and that's this unit. So what we're doing is we're making an option event. We're pattern matching on it. If it's none, we crash, and we're binding X. That we're binding. Yeah, we're just yielding what we bind. We're binding X and then yielding it, and then assigning that to Y, and then we're like returning Y. So down here at the end, well, here's our ret I2338, which is a load from I2313, which is probably a let, yeah, source let. So, and the this match creates some branching, right? So the first thing we kind of do, well, we jump into the first arm condition. There's only one arm of this match, so this is a bit of a trivial match, but you know, the original origin doesn't check for a matching condition if it only has one arm. This could be a switch. It's the same construct that match and switch use. It's just that this is one arm. So what we could do is not generate this branch altogether by checking that we only have one arm. But even one arm can have multiple conditions, and those each need to be basic blocks. So I think it's fine. Anyway, so we go into the arm condition, and then we'll see our first actual branch, right? If the tag is 1, which means if it's sum, we're going to go to continue. Otherwise, we're going to go to, it's just called armcons, but it should be, the armcon of our fail arm, I think, is how it's code-gen, which just goes to, it has no conditions. So because he has no conditions, his jump goes straight into his cons, and this is our like else arm, and it's the crash, right? So ultimately that's the crash path. So we know this is the crash path, and this is the success path. So we go to this block, which is here, and we offset into the our option int. This is our option int, you see. It's a U8 and then a union with just an I64 in it. We go grab this part. So we're pointed at union I64 basically. And then we're gonna copy 8 from there into I2222. I2222 is probably X, the sourcelet, this one. And then we're gonna copy that value into I2225, which is probably Y. And then we're actually going to jump to, not to there, but to here, which is, we're done with a condition. So this is where we go if the condition succeeds. We're going to basically dereference Y, local Y that we just stored that payload into. The integer is in Y right now, and it's an I64. So now there's an I64 and I2228, and then we're gonna go to, boom, our match end, which has a phi, which says if we came from that arm, then I2228 is the value we want. And you may notice this phi has only one condition. The only thing we could have come from is this block, and let me check, no chatters. The only thing we could have come from is this block, and so it's gotta be I2228. So this can just become, this instruction can completely disappear basically. We can just like redirect the match end to point at I2228. So that's what we're going to try to do. Let's like take a snapshot of this here as, you know, the code that we're trying to fix. We'll just throw it right here in the source, and then we'll go into that IR and go up to where we generate the phi. And so, and here we are. So where we are is inside of compiling a match. I think we have a match here. Let me see if I have anything simpler that has a matching condition in it. No, I think it's going to be a full-blown match, which is part of why it's overly complex for this simple one, because it supports many arms, all with many conditions, with making bindings intermixed within conditions. So yeah, but let's get back to it. We're definitely here. So we're compiling a match expression. And the first thing we do is we say, does it produce any data? If it doesn't, then there's no phi at all. If there is, then of course we make a phi, and that's fine. I think we need one. So we'll go ahead and push one. My thought is to go ahead and push the phi. We've already gone to the match end block. So we kind of, before we do all of the arms, we go to the match end and create the phi, and then we go back and generate the instructions into each arm. For this one, I think I'm happy still to, yeah, here's our actual incomings. So we don't really need to have generated the phi yet, but we might as well. This is a good question. Can we just wait? Because what I'm going to have to do is replace the phi with just another instruction reference if there's only one incoming by the time we get to the end. So do we just not? Yeah, let's just not make it. We're going to match end block, and all we've done is jump to it. Yeah, so let's do this. Let's not have result fee bound yet. Is empty is needed for only at the end as well. So in result inst kind, this isn't come from void. This is match result void. This should be probably an ice, but that's fine. And then it is okay if the match terminates. I'm your 999 sub. That's awesome. We're trying to compile pattern matches down to basic block IR tonight. Well, we've already done that, but we're trying to do it better. Okay. I think we don't need any of this ahead of time. All we need is incomings. And now we'll go down and we've done all the arms and we have our incomings. And instead of matching on result fee, we'll match on result inst kind. And so I generated a fee. If the thing was divergent, no, if the thing was divergent, I didn't. And so I still need to not. And it's not gonna be result fee. And then all we do, what were we doing before? We need to produce a value at the end, right? So it's empty, it's just we're using Rust. It's the language we are using to do this. The language we are compiling is, well, this is the program we're compiling. Well, it's mostly just a bunch of crap and comments. We're compiling this code right here, and that's called K1, the language we're building. And basic block IR is we have turned the code I just showed you into code that looks like this. Alloca, call, jump, copy, load. Every instruction does one small thing. It's one step away. It's fewer steps away from assembly than the source code is. Okay. So what we need to do now is if and that's it. That's our entire optimization. Let Cummings handle be IRMM list to handle. Great. Okay, fee inst as value. What were we doing before? If it was none, value empty, unreachable. Yeah. Okay. That's correct. And then this all goes away. Boop. Is that right? Oh, what's wrong? That's a value. That's a value. Oh, okay, okay value, okay value. Everything's right. What do you want from me? Oh no. A semicolon. All that. All that for 2 semicolons. Look. Don't tell me there's a third. Yeah, that's fine. Can't see anything because of all these underlines. All right. So now what do? We don't go to match end anymore. We don't need to. We do need to generate it because it's jumps 2 down here. And now we go to match end block. We match on what we're producing. If it produces an empty type, then we don't reference an empty instruction. We prefer to just use this constant, so we have no dependencies on the other instructions. If there's only one incoming, we don't generate a fee at all. We just use the value. And otherwise, we generate a fee with our incomings. And that's no longer an early return. And that's what I wanted to do tonight. Okay. My shoulder's actually hurting. Makes me really sad. Hurt my shoulder a week ago. Can't do dips, can't do pull-ups. Can't do push-ups. Been resting it for 4 days, and it's still hurting doing nothing. Okay. Well, we segfaulted. That's not what I expected to happen. What? Incomings. It's in mem. Let's find our happy path again. It's down here. We grab the integer, jump to armcons, we load the integer into I2206, we go to match end, and it's in I2206. And now we're loading from I2192. Ah. this, which is a load from I2192, but it should be I2206 should have been the phi value. If we remove our length 1 case real quick here, it should be doing the same thing it was doing before. Phi I2214, right? We go to match end. We have our phi. And then I know. I think it could be destination shenanigans. I have like a destination system where we lost these lines, store rich if destination. So every single expression we compile in this IR, we allow the ability, well, I'll just say dest. So, right, where to put the result. This lets us generate way better IR with doing no optimizations. The best example is if you have a struct literal. Instead of creating the entire struct literal, or a struct literal assigned to a local, instead of allocating space for the local, then generating the struct literal, which allocates separate space, and generating into there, and then copying the whole thing into the local, we just make the space, and then we say, hey, compile this expression now into this space. And that's what destination is for. So here's struct literal, actually. So if we were already given a destination, right, we just say, hey, make this struct literal in there, and this is the base, right? Otherwise, we make space for it. So, but with our match, what we've done here is we've lost the part where we store either of these into the destination. So what I think I want to do, both of these are going to yield the value, and we don't need OK anymore, and we need to put them in the destination. So at this point, the value, well, okay, if we have like an aggregate destination all along, then we shouldn't even do the phi. We should just do stores. We should just do stores to it. You know, maybe we'll do that tonight. That'd be kind of fun. If dest is sum and an ag, we should just do stores instead of phi. Or maybe that's worse, because then if you were going to try to do optimizations that remove aggregates, it'd be harder because it looks more like memory ops. I don't know, a phi where the values are addresses to structs also looks a lot like memory ops though. We could. This is not a to do or no commit. This is a this is an interesting thought. And I guess even if it's a scalar, we could just do store to it. But what we'll do for now is what I was doing before. Store rich if dest. Builder, dest, pt, value, fulfill, match, dest. Let fulfilled. And so like in a case like this, the destination isn't buying us anything because we haven't chosen to do the real work of compiling each arm in a destination aware way, but that's fine. We just have to remember to store it there. And then, you know, it's no harm, no foul, no gain, right? But if we did decide that this was a good idea, then the destination system is allowing us to save this entire fee, which is kind of cool. The other thing the destination system does is cause me to miscompile all the time because I forget to store to the destination in cases like this. Boom, there's 42. So that's better than a seg fault. And hopefully what we see here, matching con continue, we load from I2216 and I2219 holds our int. Then we go to match end and yep, what we do is in our match end, we just fulfill the destination. And then we immediately turn around and load from it because our whole match was just storing to a variable, right? The match is the right hand side of a let, and then we use the let the next line, and then that's the right thing. Let's try to run the whole test suite with this optimization, and it works. Let's try to run everything with this optimization. I'm compiling this right now. We were compiling these 2 lines of code as a test because this is part of a larger program that failed when I was with inlining on. So it makes an optional int, it matches on it, assigns the value to a binding, then yields it, then assigns that to y, then returns y, and oh, that's sad. We're missing fee. But maybe I'm not quite ready. Yeah, right. Without optimizations, do we pass? Or did we break something? Seems kind of impossible to get that particular error. Nope. Yep, has no value for this instruction on the stdlib test. Okay. How is that possible? And if there's a dest, this returns it. Yeah. I don't know. We're pushing the fee into match end. Should be okay. So I think it's anywhere that we match that we do have more than one arm when we're actually hitting this branch. So how does this look different than what we were doing before? Fiance, if there's a fee, we were getting it, and then, yep, store rich on the fee, and that's, we're doing that. We're doing all of that already. We don't need to do the rewrite because we're building it here. So let's just run one of the ones that's failing. It's weird that still lib's failing, but not, okay. Code generator has no value for this instruction. And it's a fee with a big type. Whoa, that is a big type. And a lot of arms. And now why is this? I want to print the IR, come on. If I leave source on, it'll be easier to read, but also harder to read. All right, let's take a look. So, we get to I3799, something refers to it, and we just don't have it. So it's in match end. Oh, it's like going out of order. Who refers to 3799? Uh-huh. So what's happening is, let's go top down. This is a long, geez, what is this? I think this is my JSON parser. Whoa, yeah, it's my JSON parser. This is kind of cool to see. Oh, so this is JSON. Neat. Let's turn off the source because I need to fix the alignment. We'll be able to see the code much better this way. Take a bite of a cookie. Yeah. Confirmed. Okay, so I'm jumping backwards through usages of this term, and this match end block just happens to be way down below. So because we moved the generation of the fee itself down, Cogen is failing to know what it means when it sees it out of order. So the question is, why do we generate it this way? No one should really be talking about the match end fee until code that comes after it. But I mean, it has to be code that's in here. But no one even has its ID. It's because of the order of the blocks, right? Because all the ARM blocks, are generated. And Cogen's going in order of the, it's just iterating the blocks. And it does all the ARM blocks and it sees the, well, no, these are all here. And then the match end is at the end of them. So then we do all the ARM blocks and then it should not see the match end, the fee, until it's done all of the arms. There's a fail block, but it also can't see Yeah, I mean, it's hard to reason about the order in this example because it's so big. But we're clearly, and both of these blocks are called match end, right? So there's two matches going on. This match end goes to another match end, right? Who is somehow earlier, but talks about he talks about I3708, which is the return value. That's cool. Oh, look at that. My RVO is working. Ret. Yep, I3708. It shouldn't be possible to, maybe that's like a miscompilation because I'm saying I'm going to return this, but then sometimes I don't. I return. Oh no. Yeah, that's bad. So I can only do that if it's the only return. Yeah. Okay, I need to make a note of that. Whoops. So this this is flawed in the case where there are multiple returns. Only this one will actually return the returned alloca that we make, which is malformed. Yeah. Bummer. So why would match returns appear inside out? This is the only match end in the whole thing. Because the way I'm imagining it is we'd be like match 1 and we'd have like arm, fail, end. And if one of the arms had a match, right, bear with me, then it would be like arm, end. And this end would come first, and it wouldn't talk about this end. It doesn't even know about that instruction. But what I feel like we're seeing is this inside out thing where we have an end, we have a match end block, 124808, which talks about this phi. Oh, at the end, right. And an earlier block, 24808, 23480, an earlier block that somehow talks about the destination. Because it's a dest. Fulfill match dest. Is it when I compile arms? Compile expert none. Compile expert none. So the problematic instruction is a fulfill doesn't make sense to me. Because the arms, when they call compile expression, they don't give a destination. Although they could, and if we were doing the storage thing, then that would be, I think that would be it. That would be all we have to do. It would be like a half of a liner, which is nice. But yeah, they don't, which means they're not going to be talking about an outer matches destination. So where are places that I like make a destination, but I put it in a later block? Like that's going to be the culprit. Like maybe if I keep the source code view, it's going to help us. And I can also improve the print. So the problem with the print right now is we're giving way too much space to the source code, and it causes things to wrap. And the comment needs to come sooner. So we'll do the instruction. If show source, we're only going to show 40 lines of source. 60 columns of source, fine. And then let's just try and like tighten all of it, because that's already padded. That can be tighter. The goal is just not to wrap because it destroys the readability. Okay, these are all wonky, but it doesn't look like we've wrapped anywhere. So let's find our problematic. So this match end is switch C. This is it. Okay. And just like that's the last one. The later one is switch C. The earlier one is if p.peak is some C. So it's true that's earlier. And his end wants to store its result into 3708, because this is what's being returned. Okay. $3708 is being returned. Okay. 3799 is the problematic instruction. Okay. So when this guy finishes, this should be like at the end of the whole function, I think. Right? And we should have already seen his body, and then yeah, great, copy I3799, which is the big phi, the result of this big match, into the ret slot. But this is further down. Why is it further down? So for a return, I think we are doing this thing. And is it, what's the comment attached to this one? RVO storage, yeah. So we push an Alica, and then we go to compile that whole thing, saying store the result in here. And then we push a return. But this block is going to yeah. We're just pushing the return from wherever we end up. I think so this is a match because we're returning this whole thing, and that's fine because it jumps us into the match land, and then it's going to spit out all of its blocks, and by the time we get back here we'll be in its match end, and we push this red, we're pushing it into the match end block, and the line that fulfilled the match destination was the problematic one that talked about I3799 before it was generated. Fulfill match. So this is using this, which is the fee we just made. No, it's the single arm one. So it's this one. I think this is a single arm one. Well, there's an else. I don't know. And then what does that mean? It's one of the values from our arm blocks, which come before. So we will have seen them all. I don't understand cogent llvm. So yep. Make an llvm block for each of our blocks. And I even take special measures already. So what do I do for fees? We don't run the incomings. Oh. So I think I used to have a fee, and now I used to have a fee, and now I have a value. And what I did for fees was what it says here. I didn't evaluate. I didn't try to resolve the incomings. I did it later. And I thought that was because of fees needed to work that way. I think that was just papering over a bug, because now that it's a single value, it's literally like, well, I don't know which type of instruction it is, but it's not one that we skip. So I'm blowing up because I run into it. So I think this has always been, this out of order problem has always been a thing. And it's not really anything to do with fee. It's more like how I generate, it's more like how match spits out stuff in a weird order that I still haven't fully understood what's wrong with the order. But I know, because then what I do is I go through all the fees, I actually make a fee, and then I resolve them once I know what all the instructions mean. So I think it's just a matter of like looking of getting a shorter example maybe, and understanding why the block that creates this fee is after the one that consumes it. It's like chiasmic, like inside out. But well, no, like that's correct. It should be inside out. It should be like nested down, like how I drew it. How I drew it in the file earlier. I don't know where I drew it. It's not that many blocks, right? I wish the names were unique. So I see a match end pretty early. Oh. No, yeah, that's 100% why. Oh, this is why. All right, because this looks like it's gonna have things be in the right order, because we'll have all the arms and then the fail and then the end. But that's going to go ahead and insert these, say the first 5 blocks of the function. And then we're going to run the arms, and then if those make blocks, they're going to be later. So what we want to do is like not, we just don't want the match end block to be here. We want to move it. So what I could do is allocate it, but not insert it. Or I could insert these before. No. Because this is all happening as part of compile expr. So they wouldn't know not to be at the end. Push block. I mean, it's a delist push. And that's what creates the node. I think this is how I want to fix it though. I think I just want to put the end at the end. Maybe there's a better way to do the cogen, to like just follow the jumps or something. Like just do it in CFG order. That'd be cute. I could do a fun thing here where I just remove it and put it at the end, and then it's going to be correct. If I don't create it yet, then the problem is this guy. For divergent matches, oh no, for non-divergent, so for every, yeah, the consequence need to jump to match end. So we need to know what it's gonna be. Yeah. I'm gonna do this. Okay. Is this gonna return mem? Match end block is just the ID. And the ID refers to it in its place. Damn. Well, if I remove it, because it's the whole node, yeah. If it was just the block, yeah, that's what I want. I just like want the instructions. Well, it doesn't have any instructions yet. But we need to keep the same handle. So we just need to rewrite that specific node. Yeah, it's kind of like my list isn't set up very well to move it. Maybe cogen just goes in CFG order. That's cute. I mean, gosh, I should be able to move an element in the list. Preserving its ID though, because its ID is an allocation. Yeah, I just have to rewrite. What its predecessor and what its last and next are on the node. it would be good. Like the whole point of this is that we can reorder things and preserve their IDs. If I did remove it, this thing still exists and it hasn't changed at all, so it's gonna be wrong about where it points, but that's okay. While keeping the handle the same, I could update previn next and move it to the end. It would be easier to read too. Do this move to end. So like let old node equal, this is gonna be bad, but let's just see. Get right match end block. Just do this in here. And that's like just it. And now we're gonna remove it. And now we're gonna push it onto the end. And it's gonna be the old node.data. Oh, and then we don't care. Its previn next will just be fixed. Is this the Cogen stuff where having everything be list-based makes your life harder? Yeah, so, well, what I made everything list-based so it would be easier. Because we want to be constantly like, for example, like merging these two blocks together, or like moving, not reordering them. Like actually, this is the first time I've wanted to do that. But so now what this is a doubly linked list of blocks, which allows me to not care about their indices and like reorder them and move them around without breaking everywhere. Like, you know, every instruction that talks about a block now has like a stable ID to talk about it. Previously, it just talked about like the 9th block, which meant, you know, if we did a merge, yeah, it's just no indices. But partly because Rust, well, largely because of Rust, even with doing all of the most heinous, unsafe things I could do, the ergonomics are still just really gross. Yeah, it's all an arena. So that's what this mem thing is. So basically what I added are, you know, everything from here down, delist, new, push front, you know, all like the usual doubly linked list things that you'd want. And so it works, and it's definitely like solved. Split at node is important. It solved what I wanted, but like look at how many variants I have to iterate because of like, sometimes I want the 32-bit handle. Sometimes though, like the problem too is it's a linked list of these blocks, and each block contains a linked list of these instructions. And Rust just like, it really doesn't want me to mutably hold or to hold on to, you know, so imagine iterating the blocks and trying to mutate the instructions, right? Like Rust, it's all one arena. So like we just have to bypass the lifetimes all the time, and it just kind of ends up gross. So, you know, just to iterate, I'm like B, K1, IR, mem, delist, iter, handles. Like this is, this should just say for self block in b.blocks, but you know, it kind of sucks. The capacity is forever and always. This arena is backed by a call to mmap, and so it'll just page in more memory if we need it. In practice though, it uses like 2 megabytes, even when I do like tons of rewrites and optimizations on like the biggest on all the biggest code base I have. So it's fine. Uses a couple KB when we don't do optimization. But yeah, the point is that the stable IDs are pointers or 32-bit offsets. That's what these node handles are. So we can't resize. I mean, we could resize. We just would want to make sure that we don't do it while holding on to any like pointers. And all of the pointers are like temporary, right? It's all, well, like while you're iterating, that we have to do all this stuff, but it's just really gross. Yeah, it's not even that big of a virtual alloc. Like I just say that like I think the max is actually like 4 gigs. I don't like say, you know, a terabyte virtually or anything like that. If this compiler's ever using 4 gigs to store IR, I kind of just want to know about it and think about it. But yeah, I don't know. It's my first doubly linked list and a single buffer backing in Rust, and it went about how you'd expect, I guess. But that's okay. See here, speed up blocks. So here's a great example, like our builder, right? So what I need to do is, oh yeah, it's just no fun at all. It's because it's inside B. Yeah. Yeah, I've learned a lot. So do I regret picking Rust? Yeah, it sucks right now that this whole thing is in Rust. There are so many good things about it though. Like even if you want to write really unsafe code and, you know, have a VM that's just like slinging, you know, let's add 4 to this pointer and hope things are fine. You know, even with all of that, like Rust feels like a great choice still, because the primitives like around doing memory and slice stuff, one, they have so many UB checks built in and like safety checks that like it catches a lot of things for me, which is like super nice. I think it'd be harder in C. So like I kind of like unsafe Rust. The problem is, I don't know, for like the really, really low level stuff. The problem is like the mid-level stuff, like the large code base where like, okay, like look, I have an IR builder, right? And like he needs a mute ref to the entire God object of the whole compiler, right? Because otherwise I can't get anything done. So, you know, no one can do anything while this builder exists, even though this thing's never going to move, right? And now what I want to do is I want to remove a node from these blocks, which is might change first and last, right? So, but sorry, like the memory arena lives inside like the, you know, the IR's mem, and so does b.blocks. So like can't do it, right? So I would have to do like let blocks. This type is copy, so it's fine. I can pull it out, and then what I would do is I would mutate this local copy. It's just updating first and last, and then I have to, you know, like restore it. So it's just, you know, tiny shit like that all day long, like gets pretty old. So it'd be really fun to rewrite the compiler in K1. I think it'd be a great language for it, but I want to get a little bit further along before I do that. Will this work? I think this will work. It's like move to end, move to beginning. So, I mean, we'll slap a big no commit on here. This sidesteps codegen llvm order, which wants to know about instructions before they are used for some reason. So neat solution might be to just do llvm lowering in CFG order instead. So I'm piling up a bit of a body count of no commits this session, but if I can get this working, it's a nice win, and I will have fixed an actual bug that already exists. Failed general declaration. What does that mean? Jump to non-existent block. Well, okay. I guess this didn't work. What did I do wrong? Oh, that changes the ID. Yeah, I can't do that. So it can't be like a normal push. What I want to do is literally rewrite the end. Yeah, partial borrows are important, and this looks pathological, but you know, this is actually, if you're smart about how you structure things in Rust, you can get away with things sometimes because it understands that the members of a struct are mutually exclusive. So as long as things aren't hidden behind functions, then I can mutably borrow different members of, for example, K1 or of IR, you know, at the same time. What that means is you can't put anything behind a helper function that like borrows self. Manually coding like the Stone Ages, exactly, yeah. Yeah. Yeah, so you've experienced it too. But I don't know what recourse there is but to have a God object. If you split it all up, you just have the same thing, but you have to pass 5 params to every function instead of 1, I think. Or if you pick the boundary wrong, you're like completely up shit's creek because you got to rewrite everything, move it around. It's tough. It's tough, but using the arenas everywhere, I mean, it's insane. Like the compiler is 1,000 times faster than it was when everything was a vec. It's truly insane. What a difference it makes. Yeah, I might I'll probably call it a night as far as actual coding. So what we did is we here in IR where we compile match expressions, we checked at the end of the match if there's only ever one arm that produced a value that we're incoming into, instead of generating a fee, what else did I do? Yeah, I think that's right. So but we also fixed the thing in the doubly linked list. Let me go, yeah. So if there's only one incoming, then we just produce that instead of producing a fee. And what this will do is there will now never be a fee with only one incoming. And what that will do is fix a bug with inlining currently, where if you have a block, if you merge 2 blocks together, and the latter one contained a fee that said, you know, come from prior block, then that fee will break. But it's stupid to handle that case when, like, that's a useless fee anyway, because we know that both of those blocks, like, that the prior block only has one successor and the successor only has one predecessor, because that's the whole reason we're merging them. So the whole reason I decided to do this was so that I could have the invariant that fees always have more than one incoming. And then that way inlining will work again. than a proper deterrent. Using the arenas versus, it's not about indirection. It's about making, really what it is it interacts really poorly with the way Rust works, where you need to make temporary copies all the time to get things done. And those temporary copies have to get dealloced, right? And the moment you have a vec with a vec inside it or something that allocates, which is super common, you have this recursive deallocation thing. And there's just so many places where you have no choice but to mutate while iterating. You're not mutating the things you're iterating, you're mutating something else in the compiler, but it all lives in the compiler. So you have to clone it. And then it's the deallocs of that recursive clone that just like, it just destroys your performance. You profile the thing and you're spending 98% of your time in destructors of like vec and hash map and box and things like that. Not to mention, of course, things end up like much more local, so you cache it all the time. But I really think it's all that deallocation. Yeah, I don't know. This doubly linked list stuff is an experiment that I don't know if it's gone that well. But in the core of the compiler, like if we can find a place where it works great. I don't know. Here's a good example, right? So it's a type definition and I need to iterate over the parameters, right? Well, where do those live? Well, they live on this parse type definition, which ultimately lives in the AST, which lives on self, because I need to mutate it sometimes. So if iterating over type params caused me to borrow self, then I couldn't do anything in here. I couldn't, for example, like I need to compile this ability expression in here, like, and that needs mute self because it needs to do work, right? It just wouldn't be possible. So what we do is we iterate. So the AST also has an arena, and so we just say get n, which is like my I'm going to iterate over this slice, and we say it lives forever, so it doesn't borrow self, because there's no way to free these. So this is like perfectly fine as long as we're not going to like start iterating and then say like asmem reset, and even then like it's just going to crash immediately, so that's fine. Anyway, we're never going to do that. So we get to just iterate over this. And then what's nice about this, type params now isn't a vec, right? It's just an m slice, which actually just says how far are we into the arena and then how many items are there. So this thing is tiny and it's copy, which means basically all of my types can be copy. This one's not, because it's a little bit too big. I haven't bothered to mark this one copy yet. But basically, even when we have collections, like this ability param, has a collection on it. It's just these 32-bit numbers. Here's an example of one I haven't done yet. So sometimes in the AST, because the AST is a little bit less important for performance, just because there's less stuff in it, because we specialize the code later. So like we parse a function once, but then we make 40 copies of it. So it matters more in the typer. But like here, I have 2 ecovecs still. So if I need to work with a parsed ability, right, and iterate over the functions and then also do stuff mutably while inside, like it's kind of a problem. I have to clone it. Now this is actually already a thing it's like reference counted. So it's fast to clone because it's actually just doing an RC increment until you mutate it. And when you mutate it, it like makes a new copy for you. So ecovec's already built for that, but they're like big and like it's still really slow to like decrement that RC all the time. So I got to replace all of these with m slices eventually. But We're almost done. Most of them are replaced. Yeah, definitely give it a try. I mean, I don't, it's hard for me to recommend this way of doing things. It's all in KMem if you want to take a look in the repo. So the virtual alloc, the mslice, the list that you can just push to, it can grow even. It has a growable list. The ecovec thing, yeah, you like every time you borrow it, it just increments the read-only count, and then there's a make mute function, which when you call make mute, it says, hey, am I the only copy? And if so, then it does nothing. And if the RC is not 0 when you call make mute, then it copies the contents. So then all of the other copies are safe, and then you're able to mutate the one you have. Make mute. Oh, I don't have any more because I got rid of them all. Nice. Yeah, it's a neat crate, but I'm trying to get rid of them. The other thing that's awesome for performance in Rust is smallvec. I use smallvecs all the time. So here's a good example, and I could use temp space in the arena as well for this, but the stack is even better and faster. So what this is an ability constraint. So I expect most type params to have less than 4 ability constraints. So this is an SV4. Let's see, SV4 typed ability signature. So that's like when you say fun foo takes a t, and t needs to implement add, and it also needs to implement sub, and it also needs to implement mul, and it also needs to implement, I don't know, print, right? So this is the things we're counting, and I just when there's 4 or fewer, then I'm putting these on the stack, and in the moment there's 5, then the smallvec is going to spill to heap, and then we will have to deallocate at the end of the function, which kind of stinks, but what you're doing is you're just banking on that being a good bet. And then if you want it to never spill, no one's going to put 8. Maybe they will, but then you're going to use a bit more stack space, and then you're going to be really fast. So smallvec, let's see, yeah, 38 instances of using smallvecs for things, which is cool. I use it twice as often as I use the temp arena. So yeah, smallvec is awesome, and that would be hard to do in C, and just having, yeah. Don't get me wrong, there's a lot of things that are so annoying about Rust, but it's also pretty, it's pretty great. And you can get used to a lot of the downsides, right? And learn to work around them, just like people do in C. But compile times also kind of stink. And I'm trying to use fewer and fewer crates, so that's not really an upside. But I do use some really valuable crates. I don't know. For the LSP stuff, I mean, this would only take a day to recreate the JSON. So, I don't know. The built-in hash map's really good. But actually, most of these I kind of hate and could do without these days. I hate bit flags. String and turner I need to replace with my own thing so that I can predict when it is going to resize. So I don't know. What else? What was I doing? Right, we're talking about compiling these fees, and now our out of order. Oh, the other thing I fixed, which is stupid, but I did at the beginning of the stream. I spent like the first 20 minutes hunting down a stupid bug where when we try to iterate an empty delist, this assert that the node is mine check fails because it's nil. Maybe I should just allow nils in there. But anyway, because the way we iterate from the beginning is we say, hey, just iterate from list.first, and this guy was nil, and then this safety check was checking that the nil node belonged to us, and it didn't. So we fixed that, and then yeah, we did this, which surfaced a bug in how we code gen. So I'll have to do that soon. Down here in code gen, I can get rid of all of this second pass for fees, which is nice because I think this is just covering over the other bug where, what do we do? So yeah, we're iterating over the blocks in that order. So if we were to do it in CFG order, we'd have like a something like this, and this is the type of place where like these days I would reuse this vec, or like use the stack or use temp. I wouldn't do, I feel like these temporary allocations are the ones that are a problem, because then I mean this isn't a hot function, but like you call these functions in a hot loop that like, you know, allocate temporary buffers, and then you're just freeing them all the time for no reason, because you're gonna need them again the moment you call this function again. We'd have this guy, and then what we would do is cogen block. Maybe we would like even ref mute work stack or something. So basically at the bottom, the last instruction is going to be the terminator, right? And so we could be like, if is last, you know, figure out where to go. It's either a ret, nowhere, a jump, push the block to work stack, or a jump if, push both blocks to work stack, and then return. And then what would happen is we'd finish that, and then we'd just like, while work stack is not empty. So work stack, we'd push, blocks.first, right? And then, yep. While at some block equal work stack pop. And let's actually do this. What the hell? I got like a couple more minutes. So we'll do this, come in here. And typically I'll prototype with vec, right? And just allocate everywhere. And then if I keep the code, I'll just spend 5 minutes updating things to reuse buffers or use the arena. Works kind of nicely that way. Enumerate. Yeah, so we do this. Maybe it's even better. I don't know, it'd be nice to do it down in here, right? You know what this does too? This for free will do dead block, like unreachable block elimination when we lower from IRA to llvm. If we do it this CFG way, we just won't ever compile the blocks that no one jumps to. So that's pretty cute. Oh. I don't see, dude, everything is different. Like with the delist, like I don't even know the length. I don't even know if it's the last. It's actually not. I don't need the, what I need is I need the node. I need the node handle so that I can compare it to block.data.insters.last. Oh well. It doesn't actually matter. Any of these instructions are going to be last and are going to be a terminator, so it's kind of like a moot point. But I don't want to pass the work stack down in here because it just feels like too much, but I can do this. That's Scala. Is it lazy like in what I compile? I will type check. Like it's like it feels normal. Like all the code gets type checked. Like even if you don't call a function, it's getting type checked. So I don't think Zig does that. But where it gets lazy, and I wouldn't even call, I guess it's lazy. Like where it gets lazy is in CodeGen. So when we go to compile the whole program, and this is the llvm layer, by the way, and it's similar for IR. Like we haven't even generated IR for functions that don't get called, that we don't have to run at compile time. So if we're not running a function at compile time, then we don't have IR for it. What I do here, so this is to compile the entire thing. We declare main, which causes us to generate IR for main. We compile all pending IR. So that's main and everything main calls, but that's it. So like if there's something that doesn't get called, we're not compiling it. And then this is new. This is my optimize before we do llvm. And of course llvm is going to optimize things, but I want to have my own optimizations as well. So that's kind of why we're doing all this stuff. The smaller and better the IR that I hand to llvm to, the faster things are going to be. So that's another reason I want to have my own optimizations. Although our IR is already really nice. Like it looks super lean and good compared to what a lot of language front ends spit out. But it could be much better. So yeah, lazy in the back end, basically. But we'll still type check all the code. I think it's just jumps. What? There's return, but return doesn't, yeah, it's just jumps, dude. This is amazing. This representation, basic block representation is so easy to reason about because of the fact that like there's only one exit from each block. It's like so nice. And there's only one way to leave a block, like to go. It's just jump and jump if. This is kind of fun. Generics in Zig generics are only checked at instantiation. Yeah, because they're not generics. It's just calling a function. So that makes perfect sense, right? I have full compile time execution and generics. K1 generics are real generics. So fun add Oh, we already have it. Yeah, fun add a generic add a b a. Sorry, we'll get there. We'll get there. It's late. B. God. All right, we did it. Read it. Okay. Are you ready? What's it gonna do? It's gonna say call to add with self is of type tick A does not work. No implementations found. So this is checked even though we haven't called it, right? And if I say that A implements add, we're good to go. A implements add and sub, and then we can subtract. But if we didn't have sub, it doesn't work. So it's real generics, but we also have full compile time execution. Because I think that they're, while I totally get that you can implement, you can simulate generics with compile time execution, I don't think it's good. I think it's kind of kludgy. And real generics with type classes is way better. Look at this. We can just run main here at compile time. What if it were 43? Now it's 43. Woo! That's pretty cool. Best unfinished language in the world. I can't wait to use it. Okay. Are we insane? Are we geniuses? Compile the first and then just like work stack? Let's log it, right? Work stack is. This is so good. I don't think that these implement debug. Gross. Yeah, so I think that might have been like the arbitrary functions. Where this function will only take a type that has no password field in it. Just like a goofy example. It could be no padding. I don't know. Or like smaller than 52 bytes. Who cares, right? And it's just an arbitrary function over a type. So this gets checked because this function this predicate constraint doesn't give me anything new I can do with T. It doesn't really have any bearing on the type checking of this. So we do still type check this generic function as a generic, and then we also check it on instantiation. And on instantiation, you have to pass the predicate. So I did do that. Is scalar here? Like here's an example of one. These are all a little bit too trivial, like to be what you would actually use this for. But the point is that, yeah, you can do really complex things if you wanted to lint and guard against things in like certain functions. Yep. You can also like, if you don't want to use generics, like guess what else you can do? Like, and I want to do better macros for this. you can do this. Right? Actually, is that gonna, yeah, that's, so the thing about meta programs is those are only gonna run on instantiation. So this kind of gives you the templating vibe, right? Let's try it. Generic add 10, 20. That's gonna work fine. So we generated a meta block. It's just, yeah, it's x plus y. But if we did foo bar, something that doesn't implement plus, we should meta, yeah, so then this calls it should fail type checking. Yeah, that's what it generates. What if I do it regular? I don't know. We should be failing. We should be failing to type check this guy. I don't know. Analog. This would be more macro style though, right? More like the operating on the text. Oh. No, that's why, yeah. Because I don't have a way to like interp, yeah, these values back in. So it's just spitting out the string. That's why. Yeah, and there it crashes. So I kind of lied that you can do that, but you will be able to. Like the spirit of what I'm saying here, like, you know, splicing those in, and it's more like just the text of that program. Like you'll be able to do that. Once I do the token-based macros. Oh, really? All right, we'll do that. So it only happens when we match inside a match. That's where one is returning. Oh, do you think it would help if we ever removed? No, we do remove things from our work stack. What did we do wrong? Are we compiling loops in a loop? Yeah, because what I've said is I'm gonna follow the CFG. So, right. So if we've already done one, what I should do is keep track of which ones I've done. Yeah, it's totally a loop. And that's like the loop, entry point. I don't know, I think this is promising. We never do it this way. Don't judge me for anything you see right now, for I am tired. This is a Hail Mary. This is gonna work. Basic blocks don't have terminators. I didn't change anything. I didn't change anything. Fine. Woo! Okay, so it works going back to the old way. So something about this is causing us not to have terminators. What? What? I need to remove all this delayed fee stuff. That is going to be so nice. Oh, we still ran into one. Has no value for this instruction. Motherfucker, it's a fee too. That doesn't make any sense to me. The work stack thing worked though. What was with those no terminator errors? It's not what's happening now. Maybe I just had it not saved or something. Damn. We got further. Okay. Yep, so you're here in a fee and you appear 415. No, you appear in an earlier block. But we just haven't been to you yet, visited you. Oh, maybe it's like because it's depth first. Yeah. Would need to be more breadth first. I don't know. I need to do some reading about this. I'm not sure what order we should try to code in these, or if I should just make it not care about the order in some different way. It's kind of a cool idea though. It's pretty funny that we looped by following the loops. So that's kind of fun. Well, thank you for watching. See you next time.